Hello, Mr. Mailer here, your online math teacher, and welcome to my channel. Today we're going to be continuing my series on analyzing functions from a pre-calculus perspective. And if you find this video helpful, please consider smashing the like button, subscribing, and checking out my other videos. Now let's get going. So today we're going to be talking about maximums and minimums of functions. And the first thing we need to do is talk about what does it mean to be a maximum or a minimum. So the definition, a number f of a is a local maximum value of f if f of a is greater than or equal to f of x when x is near a, and similarly a local minimum value of f if f of a is less than or equal to x when x is near a. Now, just because this is the definition, here's what you intuitively want to think. So let's draw a picture. So here's a picture of a function f. Now, all a local maximum is saying is imagine if you could shrink yourself down and walk on top of this function. So I'm going to draw a little picture of myself here. So I got my head, my arms, and my legs. When you're at the exact spot where if you look in front of you, if you were to keep walking, you'd be walking downhill. But also, if you were to turn back behind you and start walking, you'd also be walking downhill. That's what it means to be located at a local maximum. So the local maximum itself occurs when, let's say, x is equal to a, so at this value here, and the local maximum itself is whatever this value is. Now, you can have more than one of these local maximums. Again, I'd be at one of those spots where if I'm walking along my graph, if I walk forward, I'm walking downhill, or if I walk backward, I'm walking downhill over here too. So I'm going to call this spot occurring at C for now. So that means in this picture, f of a and f of c, whatever those numbers turned out to be, those are going to correspond to our local maximum values. A local minimum is the same idea. If we're walking on our function, but this time, if we were to walk forward, we'd end up walking uphill. And if we were to walk backwards, we'd also be walking uphill. That's what it means for us to be located at a local minimum value. So you're going to be walking uphill in either direction and you turn to walk. So, and again, it occurs at a location. I'll call this B. So the local minimum value itself is our function f evaluated at that location. So this is the rough idea of a local maximum and local minimum. Now, sometimes you might also heard these called turning points, and we can have as many of these turning points on a function as we want. What we can't have as many that we want is if you see the term a global maximum or global minimum. So what a global maximum or global minimum is, so a global absolute maximum is if that value f of a is greater than or equal to f of x for every value of x in the domain of f. Similarly, a global minimum of a function f is f of a if it's less than or equal to f of x for every value of x in the domain of our function f. And we don't always have global maximums or minimums, but when they exist, we can only have one. So in this picture up here that I drew, we can see that the third spot at C over here is bigger than every possible value of our function. No matter where we evaluate, it's the highest up I'm ever standing when I'm walking along my function here. So this location is called an absolute maximum. And this is the only absolute maximum we can. We have two actually local maximums and one local minimum here. The local maximums we said were So we can see that illustrated here. Unlike that absolute maximum, though, there is no absolute or global minimum of our function. That's because no matter what, I can always find a spot when I'm walking along my function that's lower than it was before. So this value of b here is considered a local minimum. Now we know it's the local minimum, but there's no global minimum because of our arrow signs on the left and the right both indicate that our function is going to continually go down. So because of these arrows, we have no global minimum. And in pre-calculus, you're going to be analyzing your functions mostly based on the graph. So you're very rarely going to be given a function and asked to say what its local minimums, local maximums are, unless you know its graph, because to find them algebraically, you typically need calculus. So let's look at an actual example of a function that you might be asked to look at in your class. So here's a function I've already graphed on Desmos. You can see the function over here on the left, and we can see that the turning points, or local maximum, local minimum, are precisely here and here. So we have a local maximum of approximately 8.745 occurring at the value x is equal to about 0.31. And we have a local minimum value for our function of negative 4.745 occurring at about x is equal to 2.69. Now, Desmos is a good program to use. I encourage you to do it. It'll automatically mark important features of your graph like these. Do note that it rounds these values to 3 decimals. So these are rounded values. They're not exact. And also with this function, since it continues to go up and it continues to go down, we're not going to have any global maximums or minimums in this problem. So I hope you found this video on local minimums and local maximums helpful. If you did, smash the like button and check out some of my other videos. And have an awesome day.